The beep. Oh, speakers are off. No beep. All right. What I was saying on the last day and what I mentioned just now is the following. You already know how to do this because you already know how to do this. 2x times 3x. Do not tell me the answer. Tell me what you did to get that answer. I'll wait quietly to let my voice rest while one of you tells me the right answer, or asks your friend to tell me the right answer, so when we go to the movies, I don't know which one of you likes math. You see what I did there? Come on, that was funny. Sarav, come on. That was funny. Come on, Sarav. All right, what'd you do? Mathematically speaking, what is happening there? He waited patiently while his class of grade 11 pre-calculus on their way to university students puzzled through this intensely difficult question of multiplying two polynomials. Go. Pardon? Yes, multiplication. Good start, Akshay. Well done. Did Navjot tell you it was multiplication? Is he the one that likes math? Oh, I see. Okay. All right. Yes. Well done. We are indeed multiplying. Excellent. Now tell me what you multiplied in order to get the answer, which you know automatically, but I need you to be thinking about what you actually did. Because when you think about what you actually did, that makes what we're going to do today with radicals very, very easy. You did coefficient by coefficient, which was 2 by 3, and then you did x by x to get an answer of 6x squared. Now you all knew that answer immediately. There is no reason why I had to wait as long as I did for two of you to tell me it was 2 times 3 and x times x. Right? All of you know that too, which means you all already know how to do what we're going to do today. But if I said go, you would all be like, "Ah." I don't want you to be, "Ah." I want you to be, yeah, I got this. Okay, so we're going to review it. What would you do if this, instead of being 2x and 3x, was 2x and 3y? What are you doing to us, Myers? Sophie? Again, it would be 2 times 3, and then it would be x times y, and the answer would be 6xy. What is different about those two very difficult mathematical problems to which you have been posed? The base is different, isn't it? The base in the first one was x and x, so we were able to put them together as x squared, yes? The base in the second one was x and y, which means we were not able to put them together, correct? So we had to leave them as x and y, right? Everybody understand? Okay. So now, take that knowledge and tell me what you think root 2 root 5 times 3 root 6. No, I lie. Times 3 root 3 is. What do you guess to be the right answer? Talk to your neighbor if you need to. But remember, I've already told you you know how to do this. Also, if you've been in grade 10, you know how to do this. You just may forget. Following the pattern that we have logically, what do I have here, Sukman? Sukpal, sorry. I have 2 times 3, and I have the square root of 5 times 3, which is 6 root 15. Okay? Why am I allowed to do this? No, because when they were x and y, we had to leave them separate, didn't we? I still have x and y, but when it was x and x, I could do x squared. So what is it about 3 and 5 that allow me to do that? Do you think? Because I haven't told you. I'm asking you to think about it. What is it about these 3 things that allow this to happen? I'm going to have a sip of coffee because already my throat is bothering me. Oh, darn it. Max? Not darn it. I'm happy Max is answering.
Hey, wouldn't it be like they're both under the square root?
They are both under the square root? What do you mean by they are both under the square root?
Like you're, like both of them are like roots.
Both of them are roots? Okay, so let me ask you this then. What do you think would happen if it was this? 2 root 5 times 3 cube root 3.
It wouldn't be a lot.
Why?
Because they're not the same.
They're not the same, right? This and this. Different indices don't multiply. So what do you think this answer would be, knowing what this answer was? What do you think this answer is? Because again, I haven't told you, you have to actually think. Anybody, but you just gave me the last answer, so I happen to be looking at you.
Oh, would it be 6?
6.
Square root 5.
Root 5.
Cube root 3.
Cube root 3. Absolutely correct, Max. Well done. You must have had a kick-ass grade 10 teacher. It was me. All right. Is everybody cool with that? Now, here's the first 3 first 4 are exceptionally easy. So let's go ahead and have a look at them. What do I multiply here? It's not a trick question. -7 and 5. So I'm going to write -7 and 5. And what's under the square root sign? 8 times 3, yes? Excellent. What's -7 times 5? -35. Root. Now, what does 8 break down into? 4 and 2. Does 4 have a square root? What is it? So what comes out? Times 2. And what stayed under there? 2 times 3. So I get -70 root 6. Everybody cool? Everybody good? Now some of you may be saying, well, Mr. Myers, right there, why didn't you just make it root 24? I could have. Because 24 is 4 times 6, isn't it? And then I would have brought out the square root of 4 and been left with 6 under there. Everybody understand? Okay, let's look at the next one. What can I multiply them together? Yes or no? Can I multiply them together? Yes, of course I can, because they have the same index. So, do I have a choice of simplifying this 8 now, or should I simplify it later? You want to simplify it later? That's cool. So I've got 3 root 2 times 8, yes? Which is 3 root what? Well, you said you wanted to simplify later, so shouldn't we do 2 times 8? What's the square root of 16? So what comes out? So what's the answer? 12. Everybody cool? All right. What's different about C? It's a square root that has been what? Squared, right? So again, if you can't remember the pattern, what does that 2 actually mean? That means that is negative root 6 times negative root 6, doesn't it? Why is the negative there and there? Because it's part of the base. What do 2 negatives give us? Positive. So this is the same as root 6 times root 6, isn't it? Right? Now, knowing what you know about radicals, what is the... Don't give me the answer, because there's a pattern answer you can give here. Tell me what is actually happening here. That is the root of 6 times 6, yes? Which is the root of 36, which is 6. Now that should tell you the next, remind you, I should say, of the simple mathematical algorithm, which is simply something you do instead of actually, something you know instead of math. If you have the square root of anything, and you square it, you get the radicand. Everybody remembers this? Always. What does that mean for you? You needn't write this down, but square root of x squared is x, no matter what's under there. Okay? Everybody good? All right. So this one is what? Again, I'm sure all of you could figure out a shortcut to that, but I want you to actually write it out. What is really happening here? 4 root 3 times 4 root 3, which, as Sukhpal just said, is 4 times 4, and then root 3 times 3, right? Computer's frozen because it's Monday. I lie. Computer's frozen because it's a day that ends in the letter Y, so it's frozen. Root 3 times root 3 is what? 3. Because root 3 times 3 times 3 is 9. Root of 9 is 3, right? So what do I have there really? I have 4 times 4. 4 times 4 times what? 3, which equals 48. Is everybody cool with the basics? Yes? It's pretty simple, right? Coefficients go with coefficients. Radicands go with radicands. Yeah? Okay. So now let's look at E. Does E look like something you have seen in the past? Sure it does. It looks like 5x times 3x plus 2x minus x, doesn't it? And what would you do with that if you were in the 9th grade? Pardon? You would do distribution, right? You would go boing, boing, boing. Yeah? So what are we going to do here? Because if it happens once in math, how often does it happen? Every time. So what's that? when the arrow shows up. What's that? Five times 3 and root 8 times 2. So for this question, I'm going to write it all out. Everybody understand? You don't have to, but as always, when it looks a little different, some of you are going to tell me, oh my gosh, I can't do it. So I'm going to write this out. That's 5 times 3 root 8 times 2, yes? Plus what? 5 times 2 root 8 times 3 minus what? 5 root 8 times 5. So that is 15 root 16, yes? What's that? 10 root 24. What's that? Root 40. Now, what should I do with all of those radicals if I can? Simplify, simplify, simplify. What's square root of 16? 4. What's 15 times 4? 60. 24 is 4 times 6, yeah? So what comes out? Plus 20 root 6. That's 4 times 10, right? What comes out? Minus 10 root 10. Am I done? Am I done? Of course I'm done. Why? Because there is no more simplifying and there are no like terms, yes? All right. Now, what happens in this case right here? Does that look like 2x minus 5 times 9y plus 6z? Does it? So what do I do when I add binomial, binomial? You all learned a little acronym for it. Starts with an F, ends with an L, has OI in the middle of it. Foil. You would foil that, right? So what do I do here when it looks different? Is this not still a binomial and a binomial? So is this not time for FOIL? What's that one? You can just give me the answer. You don't have to write it out like this if you don't need to. What's the answer? 72 root 10. Then we do this one. Plus 48 root 20. Then we do this one. Minus 45 root 5. Then we do this one. Minus 30 root 10. Then what do we do? Simplify. Where, Jazz Carrot? Where do I simplify? I'm sorry, the 10, 20, because 5 and 10 don't get simplified, do they? What's 10? That doesn't simplify. It's 2 and 5. But it works there, doesn't it? So I do 72 minus 30. What's that? 42 root 10. And they're taken care of. What about here? Can I do something with 20? What? 4 times 5, right? What's square root of 4? So what comes out here? 2. What's 48 times 2? 96. So I got 96 root 5 minus 45 root 5. Can I do any simplifying there? What? 42 root 10 plus 51 root 5. Am I done? Yes, because 10 and 5 don't simplify. Now, a great many of you are going to try to simplify that further. That's why I wrote the question there. You're going to try and simplify that further because you see the 10 and the 5 and you think 10 and 5 should be able to work together somehow, right? Because 5 times 2 is 10, yes? But that is what I keep talking to you guys about. Knowing when you're done is as important as knowing when it's time to start. Do you understand what I'm saying? All right. Don't screw up G. What does G really mean? Is it this? 5 root 3 squared minus 4 root 6 squared? Is it that? No, of course it isn't. Don't make that mistake. What is it really? It is 5 root 3 minus 4 root 6 times 5 root 3 minus 4 root 6. And, since those are binomials, what do we have to do? FOIL. Go ahead. Now, I do not expect you to have been able to do that necessarily as quickly in your head as I was able to do that in my head. The point I'm trying to get across is that, again, you know what you're doing, right? There is nothing new here. This is still, technically, grade 10 knowledge, right? Just in grade 10, we never foiled with radicals, did we? But that's the same thing, right? Just like in grade 3, you didn't multiply 18 times 22, but you knew how to multiply, right? It's exactly what's happening here. Now, H is the one that gets me the most, not angry, but it bothers me slightly. For the simple reason that it looks so different, and you guys get scared by things that look different. Is there any reason to be frightened by H? No. I would recommend, though, that you remember that simple one-word thing that I tell you to do every chance you get. What is that one word that I say to use every time you can? Simplify. Because if you do this the way you're supposed to do it, you're going to end up with 54 times 54, aren't you? And that's a big-ass number, right? So what should you do with that 54 before you do anything else? What should you do? Simplify it. What is 54 when we're working with cube roots? Isn't that 27 times 2? What's a cube root of 27? 3. So what comes out? 3. What's already out there? 2. So this is really 6 cube root 2, isn't it? minus 3 cube root 4. Everybody cool? And then, since it's squared, we got to do it again. Now, here again we have to think. Am I allowed to multiply cube root and cube root? Yes, because they're the same, right? Now here is where, if you haven't been paying attention to what is actually happening, you've only been half paying attention, some of you are going to automatically see cube root 2 times cube root 2, and you're going to say, oh, root times root, it must equal 2. Does it? No, why not, Max? Because it's cubed root. So this is not true. Is this true? Is that one true? Yes, because there's 3 of them, so it'll equal 2. Everybody with me? So root x squared equals x. Cube root x cubed equals x. Fourth root of x to the 4th equals x. So y root x to what power? Y would equal x. Does everybody understand that? See how easy it is to get trapped when you're learning the way things look, not what's really happening. Does everybody understand the difference? So let's go back to where we were. Do you think the 6 and 6 changes? Do you think that rule changes? No. So it's going to be 36 cube root what? 4. Minus, what's 6 times 3? 18 cube root 2 times 4? 8 minus 18 cube root 8 plus 9 cube root 16. Everybody good to that line? Yeah? Okay, what should I do now? Simplify. Is there a cube root of 4? No. So this guy's not getting touched. What can I do with negative 18 cube root 8, negative 18 cube root 8? I can make, the cube root of 8 is 2, isn't it? So this is, out comes a 2. So this is negative 36, isn't it? And then what's this one? Negative 36. And what's happening here? Does that simplify? Is there a cube root that goes into 16? 8. Isn't that 8 times 2? So what comes out? 2. What's already out there? So what is it? 18 cube root. What did I leave under there? 2. Now simplify again. 36 cube root 4. Now, we usually like to keep our radicals together. So plus 18 cube root 2 minus 72. Is everybody good? What if I stacked a trinomial of radicals with a trinomial of radicals? Would you change anything? No. You just do 1, 2, 3, 1, 2, 3, 1, 2, 3, simplify, collect like terms, and you'd be done. Is everybody okay? All right, I want you to attempt 38 and 39 for today. Remember, you have a quiz tomorrow on just adding and subtracting, unless there's a little bit of multiplying like in the work, right? Everybody cool? Everyone's good? Okay, go. Now, is it beneficial, and I can check if it is, did the thing I did with the addition, doing the whole key now and putting it all on YouTube, Is that more helpful than me walking around right now? Which one works better for you guys? Because I'm in the business of doing what you guys need. I can get this whole key done in like 10 minutes, and we have 33 minutes left in class, which would give me still time to come around and help if you need it. The only problem with this plan, of course, is there's no help from me for this next 10 minutes. So if you're stuck, you need to check with a friend, check with your notes, or move on to the next question, and then call me when I come by. That is what works for you guys? Having that key to check later tonight? Yeah? Okay, carry on. I'm not going to talk, guys. Last thing I'm going to say out loud, I'm not going to talk through this key, but I'm going to do more work than I would normally do in place of me talking. Do you understand what I'm saying? Like normally I would talk and I would do a shortcut, right? But I'm not going to do that because of my voice, okay? So I'm just going to draw extra arrows and extra work. It's going to look like it did. 1 second, Kara, I see your hand. I'll do it kind of like this whole key. I'll do it like this, where I show every step to avoid talking. Is that okay for everyone? All right, go do what you need to do. Yoon, what part of you were supposed to take care of this by yourself?
Isn't all of this following this rule?
Yes. Yeah. I know. And Yoon, look what I was writing on the board. Because my whole belief, Yoon, is that you should remember stuff you did before. So by making you do this, and none of you, all of you doing it, hopefully you will then say, oh yeah, I already knew that. Sadly, it often doesn't work. Hey, Mr. Radney.
Quite the crew here.
You know it, brother.
So let me know about Friday, and then maybe one of those Sunday goalies. If you could send me his number.
Yeah, I can
Isn't
call.
one of the goalies a local guy?
Greg lives in Mission.
Yeah. But if you can make it, awesome. Figure it out. Cheers.
It's a pretty simple request. But Yoon, just ask once, man. No need to go crazy. Right? Okay. So, now the situation is diffused for everybody, right? If I'd known you asked once, I wouldn't have said anything.